Okay, so this problem asks us to calculate the wavelength of a photon that has a frequency of 5.0 times 10 to the 5th hertz or inverse seconds or whatever you want to describe that unit as. All electromagnetic waves travel at the speed of light, which is 3.0 times 10 to the 8th meters per second. We have this equation that relates frequency and wavelength right here. So speed of light is equal to the wavelength times the frequency. They have an inverse relationship, meaning that if one is high, the other is going to be low. If one is low, the other is going to be high. So that would be an inverse relationship. In this case, we're solving for wavelength. So what you need to do is get that by itself. In order to do that, you would divide both sides by the frequency and end up with the equation, the wavelength is equal to the speed of light divided by the frequency. Then all you have to do is plug in the values you were given. The speed of light doesn't change, it's a constant, 3.0 times 10 to the 8th meters per second. And you would divide that by the frequency, which is 5.0 times 10 to the 5th, 1 over seconds. What will happen is the seconds will cancel out and your units will be meters. Now, when you do these types of problems, I want you to look at the coefficients first, and then look at the factors of 10 seconds. So, when we look at the coefficients, 3 divided by 5 will give you 0.6. When you look at the factors of 10, you're dividing them, so what you do is subtract the exponents, and 8 minus 5 would give you 10 to the 3rd. So this would be the answer I would expect you to get. But you need to take that one step further and go to scientific notation. And when you do that, you have to move the decimal to the right by one place, so it becomes 6.0, and that will change your exponent of 10 to 2. Your number goes from small to big, so your exponent's going to go from big to small. And this would be the answer. So the wavelength of a photon traveling with this frequency will be 600 meters, which is rather large. We're done.